So today we're in the Langhorne Creek region on the Fleurieu Peninsula in around a 380 to 400 mil rainfall area. This site we're on is actually also an irrigated site as well, which we'll touch on as we go through this soil pit. So this soil pit we're on today is on an alluvial plain. So we're right next to the Bremer River, and as a result of that, we've been influenced by these alluvial flood events, which has deposited soil material over hundreds of thousands of years around this Bremer region. So as far as the Fleurieu Peninsula goes, we're on a younger soil type compared to some of the really old soil types that are highly weathered. These soils are a lot younger due to that fresh soil deposition that occurs. With that comes some really interesting soil profile and soil layers, which we'll go through today. So the soil is overall a dermisol soil. It's a really gradational soil type, so relatively similar texture down through the profile, starting from the siltier loams up on the top, transitioning into more of a clay loam down through the profile. We've got some good visible structure of how that soil particles are holding together. Then underneath it gets interesting again, going back to a sandier soil, which is a bit of a relic of that alluvial and river setting that we've essentially built this soil profile on. So some really interesting soil effects that happen in alluvial regions. So through this Langhorne Creek region, as we've got some soils that are really close to water bodies such as the Bremer River, we've got some influence of those soil types really close to the river setting, and then as you get further away, the soils really change quite significantly. So you don't have to go far and you won't see a soil profile like this. It could be something completely different. And this is why, especially in this region and throughout the Fleurieu Peninsula in general, we've got to start looking at our soils below the surface, because quite often the same topsoil all looks really similar as you're walking across a field, but it is remarkable how much this will change down to at least a metre across all the soil types that we've been looking at around the region. So critically, how do we start understanding our soils, one in the field, and two, then how we can do further testing or maybe send some soil samples off to a laboratory. But the important thing is that power of observation we can capture while we're here in the field. So critically, what we want to understand is where the different soil layers start and stop. So once we understand where and how they're starting and stopping, we can understand where plants, when they're growing in these soils, may find a restriction, which then helps us design what fodder crops or what pastures or what crops we should plant on top, which will then suit the condition that's going on down below. And not all of that can be explained from just a soil test sending off to a laboratory. So as we go down through this profile, we're looking for the layers again, and we've sort of got this region that's declaring itself quite nicely, good crumbly structure in this sort of 0 to 15 centimetres. So that's sort of holding together as one unit, good root material growing through that layer. Then we'll see in this next layer down, sort of in that 15 to 30 centimetre layer, the structure sort of changes. We don't have such a crumbly, nice small blocks sort of forming. We've got, as you can see, just this clearer, blockier structure coming through. Now this site has been through a series of annual cropping systems as well as pasture, but probably over the last 5 to 10 years it's been more of a dominant pasture and cover cropping kind of scenario. So over time we'll see this structure potentially change and restructure itself, and we want to really see smaller crumbly structure down through a profile is most ideal. And as you can see, as we break down into this next layer, it does still have the tendency to want to still break down into these smaller particles, but from that, call it the macro structure, so how it looks visually from a distance, is still wanting to be in this blockier sort of structured setting. Then as we go down, we're still getting more root development down through this profile, which is excellent to see. So in this sort of 30 to really that 70 centimetre range, we've got another sort of layer that's happening through here. Then under that, we can see this soil darken up, and we've got a darker layer, similar textured, but a change in soil colour. But we're still getting good root development. It'll be interesting to see what roots they are that are specifically from the crop that's growing on top for the pasture. Then as we go down, that really takes us to around that metre mark. Then under that, we'll go back into this sandier layer that we were talking about earlier. So we've really got our 1, 2, 3, 4, 5 clear layers through the profile. So once you've sort of identified that, initially by colour can be really helpful in a lot of the soils of the region, but especially when it starts getting a little bit difficult, the plant roots are really a good indicator to then potentially guide you on where another layer might be. Are they stopping at a certain layer? Are they getting more sparse in a certain layer? That can be a really good identifier of, if you've got a really uniform soil colour, where some other subtle changes might be occurring in the profile. To that point, then once we've got a starting idea of where those soil layers are, the next thing we can do is to texture those soils. So we want to understand how much sand, silt and clay are forming these soils. So all we need to do is get a little bit of the soil from each of the layer. So get a nice handful of soil, and then we'll wet that soil up. So sometimes, say, spray bottle's really handy, so we'll just need to wet that up, and sometimes it takes a little bit just to really get that soil to wet up and then work it along. So you just want to massage that water into that soil without it getting too sloppy and wet, and like I say, it'll take a little bit to wet it up sometimes. So once you've got that soil wetted up nicely, you've got that nice sort of moldable feeling in your hands, we can then texture it out. So what we mean by that is you can feel, as you're working it through, you'll feel if it's got sand in it, you'll feel a coarse grittiness, and you can almost hear the sand particles if you do that, if you've got sand in the soil crunching together. And then you've got the silty factor, which creates quite a smoothness to the soil. And then you've got the clays, which are your finest soil particle sizing. So really small particles, and they really help hold that soil together, which is where we'll get a longer ribbon. So what do we mean by a ribbon? So when we've got that soil wetted up and you want enough to sort of fill your hand, and you don't want it too wet, you just want it sort of glistening wet. So it's just moldable but holding together. Then what you want to do is work that soil through your thumb and forefinger and try and just push that out. So you want to try and get that to hold together. And then we'll just push that out through our thumb and forefinger and just see how long that ribbon is. So you want to save that, and then we'll do another one. And you kind of do a best of 3. So how consistently can we get that soil texture length? So I've got a couple there, looking around that couple of centimetre mark, so around that 20 mil mark. So work it up again, and then push it out between your thumb and forefinger. And when it naturally drops, so these are the particles we'll then measure and correlate back to a soil texture. So there's a standard soil texture charts, and so when you're looking at that was around the 20-25 mil sort of length. We're probably looking around and seeing how it feels. Don't forget how it feels, don't get too locked down on that length, but you're looking around that silty loam soil. So a real handy tool or a real handy guide is to, when you are texturing those soils out, it's very rubbery rule of thumb, but the length of the ribbon that you generate when it breaks is, if that's at 25 mils, that is roughly 25% clay. So that's a really handy tool to know when you're trying to assess your soils, that if you're in a sandier soil, you'll get a really short ribbon, which is telling you that there's less clay in those soils. Where if you go to a heavier clay soil, you might be ribboning and get 40, 50, 60 mils, and you know that that's a high percentage of clay. So really, when we are texturing these soils, we want to know what is the clay percentage, because the clay percentage really governs how much water that soil is going to hold. What potential constraints might be sitting in that profile. If we get a stark difference between a sand and a clay, are we going to get a perching layer or anything like that? And also, clay is an amazing indicator for telling us how much nutrition might be in reserve and stored in these soils. So the greater the clay content, essentially the bigger the battery is of a soil, so the more nutrition is going to be stored in that layer, in that soil. So soil texturing, really handy tool to assess so much around what the potential is of your soil. So another thing we can look at to help identify the different layers and where we might need to go investigating further to understand more about our soils is to look at the soil pH. And you can get the pH kits from your local hardware store, just a filled pH kit, which comes with some liquid and a powder for you to put onto your soil, and it will reveal a colour, and we can link that back to what the soil pH is. We can just get little subsamples, get a little bit of soil and put it onto the tray that comes in the kit and put a bit of liquid and powder on. But another great visual is to tip it out onto the soil profile. We can actually assess this as it's going through and see how that soil is colouring up down through the profile, and we might be able to pick up some subtle changes as we go. So we'll see, and we see even trying to put this liquid on, we've got a little bit of hydrophobic nature as this soil's just starting to wet up, but that's not really to worry here as we go down. So you can see this colour starting to reveal. So this colour, we can see this sort of greeny tinge coming through. That's really starting to declare its pH as we go down. Then you just give it a minute, let it develop a little as we go down through the profile. Then in your kit, you'll be linked up with a colour wheel, which we then match back to this soil profile. So we can see that colour starting to develop, and what do we see on first observation? So we see some greenier colours closer to the surface. We're getting this green blending with a bit of purple down through this next layer, and that's sort of coming down through to around that 70 or 60 or 70 centimetres. Then it goes back to just sort of a greenier colour again down in this next layer. So pH can then point us into, sort of gives us the opportunity of where we should start asking more questions. So we'll look at the top. When we match up that, we're sort of looking around that 6.5 mark. Down through this next layer, I'd be saying we're sitting around that similar 6.5 as well. What's then happening down in this layer here? In this layer, we're probably getting up towards the 7.5 and 8 mark. We're getting this purpling coming through, and then it's coming back to around the 7 as we go down through the rest of the profile. We've touched on that pH. We've got to just remember when we are going around this colour wheel and we go from a 5 to a 6, it is actually a 10 times increase. It's not just one unit, it's one pH unit, which is actually a logarithmic scale, so it's going 10 times. So 5 to 7 is 100 times, and then 5 to 8 pH is 1,000 times more alkaline. So in this profile, we're probably sitting at around the 6 mark, and then, or 6, 6.5, and going to around that 8, 8.5 mark. So you're looking around 100 times difference in pH between this 0 to 30 area and that 30 to 60 centimetre area. So really interesting dynamic there. We can look at these soils and do some other tests as well for around carbonate, which we can add the hydrochloric acid and see if it's going to fizz. But these soils don't have that calcium carbonate content in it. So when we see that pH increase, we think, there's something going on this soil that might be different. When we are measuring pH, pH is just a measure of the acidity that's coming out into that soil solution. So in the background, there can be some more acidity still attached to the soil particles. And similarly, we can actually influence the pH by the amount of salts that are in the soil as well. So what you can find, especially if you're in an area that you know is prone to potential salinity issues, which the Langhorne Creek region certainly does have that history, we can say, okay, maybe something's going on down in this sort of 30 to 60 centimetre area where we might be getting some more salts coming in, which is then leading to dragging that pH up. So that then really helps us ask the right questions of this next layer. So pH can be, even though it's just a direct measurement on that pH is what we're looking at, it is once you start understanding pH in more detail, you can use it as such a really good guiding tool to where we should be asking other questions and potentially doing some other measurement. So in this layer here, now that we've picked up that the pH has been a little bit different, I'd love to do what's called an electrical conductivity measurement on this layer down here, which is a measurement of the salt content. So what we want to know is, how does that salt content change from this 0 to 30 centimeters down into this 30 to 60 centimeter layer? Because this is potentially telling us what sort of a salt band might be sitting here, which will influence how certain plant species will grow. So we can do a EC 1 to 5, and if you've got a water meter, like a digital water meter for testing potentially trough, like stock water for troughs, or you might have a bore that you've tested water before, you can use that same meter and use a solution that's 1 part soil to 5 parts water, and shake that up for around 10 minutes and then put your meter in there and you can get a EC reading. Quite often we'll see this salt bulge happening through this region in the Langhorne Creek due to its lower rainfall compared to other areas on the Fleurieu Peninsula. So what we'll see is these salt bands will move through the layer based on where the water is infiltrating to. So salts will always move with the wetting front. So when water's moving through, it's carrying it through like a bow wave, carrying salts with it, and we can deposit them down in the profile. What then happens is, as that water is then leaving the soil, so either evaporating from the soil surface, if you've got a bare soil, those salts can actually creep right back to the surface. However, if we've got plants established in them, the water will leave through the plant roots and up through the plant leaves and leave the salt down in the profile. So there are a number of strategies with dealing with salt. Really, the only way you can manage salt is to keep on leaching it down through the profile. So we need water to carry those salts down through the profile and make sure they don't come back up. So strategies, especially if you've got the capacity to irrigate some country, is to utilize the rainfall you've got. Potentially, if you have a rainfall event, you can track that, especially if you've got a moisture probe as well. You can see where that moisture is tracking down to. And a strategy then is to be able to irrigate on the back of that and help push those salts down further down into the profile, especially if you've got a drier soil underneath, to keep on moving those salts down. So really, if you do know that salts are potentially a problem for you, really understanding your soil textures, so how much the soil is holding as far as the bank account of salt that's sitting there, how much water it's going to take to wet that up, and then push those salts down through the profile. So without sending any soil off to a lab, we've really been able to identify what the positives are of this soil, and so having a great soil texture, capacity to hold nutrients, hold water. We can see roots are moving through, but we can see that we might have some underlying issues that we want to make sure that might not be a true issue now with the plants that are growing here, but if we wanted to swap what plants we were growing, or needed to be aware that if we didn't manage this site right, we could see those salts climbing closer to the surface. So the power of understanding your soil from below that 0 to 10 centimeters is a really critical feature to really get your head around, especially here on the Fleurieu Peninsula. So this site has been used as a summer fodder crop trial. So it's had an 11 species summer fodder mix that's been planted on this site, which from this soil type is a really good example of how we can use multi-species crops to potentially deal with underlying soil constraints and keep soil cover, especially over that vulnerable summer period. So as we've got that different plant architecture that comes with these species mixes, we've gone from, like, we've got herbs and we've got brassicas, we've got grasses, so it's completely different root architectures that have been introduced into this soil profile. We've got good root growth, definitely to a metre. We've got roots definitely visible down to that 1.5 metres, but we've got really good root activity through the middle section of this soil profile, which is really important. So other sites, you might only see that root activity getting to around 50 centimetres and then declining. So the root architecture and the presence of that root material is a really handy indicator for identifying where a constraint might be in the soil. This site, there's suspected salt sitting around this sort of 30 to 60 centimetre area. So to see root activity growing in there, that's a really good sign. One, it tells us that the salts might not be too high level, or two, that the more salt tolerant plants that are growing in here, such as your lucerne, might be really active in this zone, which is then really productive for being able to manage that salt layer and make sure those salts aren't creeping closer to the top and keep them moving in a downward direction. So the value of summer fodder crops on the Flurio can be a really good strategy for managing some of these soil constraints and soils in general, and can be a valuable tool for above ground production as well as below ground soil management. So if you have any questions on soil management, please contact Landscapes, Hills and Flurio.